Okay, let's do this example. It's up on the board here. I want you to try to not just be able to get the answer, but understand why it works the way it works. So here's the example. It says explanation of why the binomial probability formula makes sense. So I'm trying to get you to more than just be able to plug in the numbers, but to understand why it makes sense, because I think you're more likely to remember how to do something like this if you understand the reasoning behind it. Taylor has a career free throw percentage of 68%. If he shoots 7 free throws during a game, what is the probability he will make exactly 5? Okay? So let's say that the first time he shoots 7 free throws, let's say he makes the first one, makes the second one, makes the third one, makes the fourth one, makes the fifth one, and then I was going to do misses. That starts with an M too, doesn't it? So let's just use blanks here. 1, 2, 3, 4, 5, 6, 7. So what are the chances he's going to make the first shot? What's the probability he's going to make the first shot? 0.68. Okay. We're assuming that he's going to shoot the same percentage that he has been shooting throughout his career. Okay. So 0.68 would be the chance he's going to make the first shot. Same thing with the second shot. Same thing with the third shot. Same thing with the fourth shot. Same thing to the fifth shot. Now, let's say he makes those 5, and then he misses. So 68%, which is our P, our probability of making any given shot. Q is the success of, or is the probability of missing that shot. So what would that be? 0.32. Yep, 1 minus 0.68. Or if he makes 68%, he misses 32%. So there's a 32% chance he's going to miss that 6th shot, and a 32% chance he's going to miss the 7th shot. And if we want this to happen, and this, and this, and this, and this, and this, and this, and means multiply, so he ends up coming out to 0.68 to the 5th power times 0.32 squared. Okay? But that's not the only way that this could happen, right? He could miss the first 2 shots. So he could miss the first shot, 0.32 chance of that happening, miss the second shot, and then he could make the rest. That's still 0.68 to the 5th power times 0.32 squared. But wouldn't you agree that that's a different way to do it? Okay. And are there other ways he could do this? Couldn't he maybe make the first shot, and then miss, and then make the next 2, then miss again, and then make the last 2? So this time he's chosen, not really chosen, but he's missed the second shot, he's missed the 5th shot. But it's still 0.68 to the 5th power times 0.32 squared. So how many ways can this happen is what we need to think about. So we learned this last chapter. If he's trying to make 5 shots and miss 2 shots, he's trying to make 5 out of how many? 7, right? So the way that we would write an expression for how many ways this could happen would be this. How many ways can he choose 5 shots out of 7 to make? Obviously he's not actually choosing, unless he's really good. He chooses when he wants to make and when he wants to miss. But so the answer to that is how many combinations of 5 out of 7 are there? Now you might say, well, the order makes a difference, so when we use permutations? Well, but if you switch like the 0.68s around, that's not considered a different combination, is it? Or if we switch these 2.32s around, that would not be considered a different permutation. So we aren't really doing combinations, because if you switch the 2 like things around, that's still considered the same combination. So this expression will tell you how many different ways he could do this. So how do you do that? Well, you do 7 factorial over 7 minus 5, which is 2 factorial, and then 5 factorial. That's the combination formula that we learned. So let's figure out what that is. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. Cancel the 5s, 4s, 3s, 2s, 1s. That's 42 divided by 2, which is 21. There's 21 different ways that I could list these out. Okay? So, what we want to do then is take 21, since this is the probability of that particular instance happening. This is the probability of that particular instance happening. This is the probability of that happening. So, but there's 21 different ways. So I need to take that times 21. So 21 times 0.68, need a little calculator help here, to the 5th, times 0.32 squared. 0.31. So there's a 31% chance that he's going to make 5 free throws out of 7. All right. Now, so here's the actual formula. So this first part, that's just the number of ways that you can have x successes out of n tries. The p to the x, that's just multiplying your chances of being successful times the number of times. So this is like here we had 0.68 to the 5th power because he wanted to make 5 shots. And then the other times you're going to fail. N minus x tells you the number of times you're going to fail. So that's really the formula that we're using. Hopefully you get a little bit of understanding of where that's coming from now. Any questions about that?